In this lecture, we're going to look at elementary row operations. We can rewrite a system of equations using a matrix. So for example, look at this system of equations. We've actually solved this system of equations in an earlier lecture. We can write a matrix that encapsulates this system of equations. Okay, now the way we do that is we look at the coefficients of the variables in this system of equations. So look at the first equation. We see the coefficients are 1, 1, and 1. Okay, so let's write that here. 1, 1, and 1. On the right hand side, we have the constant 0, so we'll write that here. Okay, now move on to the second equation. We see that the coefficients are -1, 2, and 3. Okay, so let's write that. -1, 2, and 3. On the right hand side, we have 1. Okay, let's move on to the third equation. The coefficients are 3, -3, and 1. Okay, so 3, -3, and 1. The constant term is -1. So let's write that here. Okay, so this matrix that we just formed, that's called the augmented matrix. Okay, now we can solve the system using the same three operations that we used earlier. Instead of performing operations on equations, we can perform operations on rows. The operations are called elementary row operations. Okay, the first thing you can do is switch two rows. The second thing you can do is multiply one row by a non-zero number. And finally, the third thing that you can do is add a multiple of one row to a second row. This is exactly the same three steps that you saw earlier in Gaussian elimination. Okay, let me write that matrix again. The augmented matrix was 1, 1, 1, 0, -1, 2, 3, and 1, 3, -3, 1, and -1. Okay, so this was our augmented matrix. Let's look at the first two rows. If we were to add those two rows, notice the 1 and the -1, they would cancel here. So let's do that. Let's do row 1 plus row 2. And that'll be our new row 2. Okay. So the first row just stays the same. The second row, we add these two rows. So we get 0, 3, 4, and 1. The third row just stays the same. Okay. Now let's look at that third row there. We want to get rid of that 3. So the way to do that is we'll take minus 3 times row 1 and then add that to row 3. Okay, so let's do minus 3 row 1 plus row 3. Okay, that'll give us our new row 3. Let me write that here. Okay, the first two rows, they just stay the same. Just gonna rewrite it here. Now the third row, I get minus 3 plus 3, which is 0. Minus 3 minus 3, which is minus 6. Minus 3 plus 1, which is minus 2. 0 plus negative 1, which is negative 1. And this is what I get. Alright, let's focus here on the second and third equations. We want to try to get rid of that minus 6 there. But if we were to multiply the second row by 2, we would get a 6 here. Okay? And then we'll be able to add that to the third equation and cancel out that minus 6. Okay, so let's do that. Let's do 2 times row 2 plus row 3. That'll give us our new row 3. Okay. Let me just rewrite that here. Okay, so we had 2 row 2 plus row 3 to get our new row 3. Okay, let me do that right here. Okay, so that'll give us 6 minus 6, which is 0. Okay, 8 minus 2, which is 6. 2 minus 1, which is 1. Okay. Alright, let's look at that third row. We want this coefficient 6 to be 1. So let's divide out by 6. Okay, divide the third row by 6. That'll give us our new third row. Okay, and this is what we get here. Alright, let's look at the second row. Okay, look at the coefficient 3. We want that to be 1. So let's divide the second row by 3. Okay, that'll be our new second row. Okay, let me do it right here. Okay, so I divided everything by 3. in that second row. Okay, notice this triangular shape here of this matrix, and all the coefficients along this diagonal part is 1. Okay, when you have this sort of form and all the coefficients along this diagonal line here are 1, then we say that it's in row echelon form. Okay, row echelon form.